Hey class, Mr. Andrew here. For today's lesson, we're going to be taking a look at section 13.2, which is going to deal with the sine and cosine ratios. So for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use the sine and cosine ratios to find angle measures and side lengths. So in 13.1, we talked about the tangent ratio, and we use the tangent ratio to find side length and angle measures. Today, we're going to continue on, and we're going to talk about the sine and cosine, the last two of the three common trig ratios. We're going to talk about sine and cosine, and then talk about how to use them to find angle measures and side lengths. So, with that said, let's go ahead and talk about sine and cosine. This bit of information here is the same thing you saw in 13.1, where it talked about we can use trig ratios to find side length and angles. And we talked about how to identify the hypotenuse, the side that's opposite of angle A, and the side that's adjacent to angle A, and then how that switches for angle B as well. So remember, at least in reference to angle A, the hypotenuse is always the longest side, the side that's opposite of the right angle. And then the side that's opposite of angle A is the side that's legitimately opposite of it. And then the adjacent is that third and final side. It's the side that touches or is next to angle A, but not the hypotenuse. So, opposite, adjacent, and hypotenuse. And that is going to lead us into sine and cosine for today. So the sine ratio is going to be sin A, so S-I-N, is going to be our abbreviated version of sine. So sine A is opposite over hypotenuse. So sine is opposite over hypotenuse. And then cosine of A is going to be adjacent over hypotenuse. So in the 13.1 notes, I talked about the mnemonic phrase SOHCAHTOA. Okay, and on 13.1 notes, we talked about tangent. And we talked about how tangent is opposite over adjacent. So if we look at sine, the sine is opposite over hypotenuse. Sine is opposite over hypotenuse, S-O-H. So that means so stands for sine is equal to the opposite over the hypotenuse. Again, it seems weird, and the thought of SOHCAHTOA seems really weird, but trust me, it is actually very helpful in keeping your trig ratio straight. Okay, if you know TOA, tangent is opposite over adjacent. If I know sine is opposite over hypotenuse. The first letter is your trig ratio, and then the next two letters are your fraction. Numerator, denominator. Same thing for cosine. Cosine is adjacent over hypotenuse. Cosine A equals adjacent over hypotenuse. So, we talked about tangent in 13.1 that it was opposite over adjacent. Today we're going to take a look at just sine and cosine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Now, we can find the sine and cosine of angle A at the same time. You could also do the same thing with tangent. Much like we found with tangent, when you change that reference angle, the sides that are opposite and adjacent do change. All right, so with that said, let's go ahead and get into example 1 much faster than we could yesterday. So, example 1 is going to ask us the following thing. So for example 1, they want us to go through and write the sine and cosine of each angle, and then we need to write each ratio as a fraction and a decimal rounded to the nearest hundredth. So we're going to go through and set up our ratios and then calculate our decimals from there. Now, because we're talking about sine and cosine, if we're thinking SOHCAHTOA, sine is opposite over hypotenuse, and then for cosine, it is adjacent over hypotenuse. SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. All right, so for example 1a, we have the triangle ABC again, and we have 18, 24, and 30. We know that angle C is our right angle, and the first thing they want us to figure out is the sine of angle A, and then the cosine of angle A. So let's start with angle A as our reference angle. First of all, in this triangle, 30 is our hypotenuse. It's the largest of the three sides, and it's opposite of the right angle. So now that I know the hypotenuse, from angle A, the side that is opposite of A is the 18, meaning the side that is adjacent to angle A is 24. Okay, if you find or found that it was helpful with my last set of notes in this set to use different colors for the different angles, by all means do that, or do out your work and then erase opposite and adjacent so that way you can clearly reference it. Alright, so I know that 18 is the opposite, 24 is the adjacent, and that 30 is my hypotenuse, all in reference to angle A. So if we want to figure out the sine of A, sine, the SO, is opposite over hypotenuse. So sine of A is going to be equal to opposite over hypotenuse, so 18 over 30. So then if we go through and calculate that, if we do 18 divided by 30, we end up with 0.6 for the sine of A. And that's our answer. So we're just going to go through and do that for all the other angles and their sine and cosine. We did the cosine of A, again using A as our reference. Cosine is the ka, so that's the adjacent over hypotenuse. So the adjacent side is 24, and the hypotenuse is 30. So cosine A is going to be adjacent over hypotenuse, so 24 over 30. So then all we have to do is take our calculator and do 24 divided by 30, and we get 0.8 for the cosine of A. And that's how you find sine and cosine. So the key for these ones is whatever your reference angle is, in this case A, figure out your hypotenuse, your opposite and adjacent. Remember that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. All right, now before we continue on, let's finish off example 1, part A. Set this up a little more for us. So we have to figure out the sine of B and the cosine of B. So if we use B as our reference angle, if B is our reference angle, 30 stays as our hypotenuse, that doesn't change. Our side opposite, though, is now 24, and the side that is adjacent is 18. So, in terms of B, 30 is the hypotenuse, 24 is the opposite, and 18 is the adjacent. So sine of B, sine is opposite over hypotenuse. So sine B is opposite over hypotenuse. So from B, opposite is 24, and the hypotenuse is 30. And then before I go through and calculate it, let's just set up for cosine. Cosine of angle B, cosine is adjacent over hypotenuse. So the side that is adjacent to angle B is 18, and then the hypotenuse is 30. So cosine B is going to be 18 over 30. So now that I have those fractions set up, we can go through and calculate them to figure out what our degree for these ratios are. So 24 divided by 30 is going to give us 0.8. And then if we do 18 divided by 30, we end up with 0.6. And that is our answer for example 1 part A on writing the sine and cosine of each angle in terms of a ratio as a fraction and a decimal. So key for these ones is to go through and identify what your reference angle is. So this was for angle A. Figure out your hypotenuse, opposite, and adjacent. And then remember so, ka, toa. So is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that is how you go through and figure out the sine, cosine of different angles and figure out your ratio. Now, I'm actually going to leave part B if you want some extra practice on identifying it and what your ratio should look like and then what your decimal should ultimately be. I will leave those for you to do and kind of run through on your own. They are done on my completed notes for you to look at if you would like some guidance. If you kind of want to pause and then run through it real quick, what I will tell you is that the sine of D, when you get to your decimal, should be 0.47. The cosine of D, you should get 0.88. The sine of F is 0.88. And then the cosine of F is 0.47. So understand this. If you want to pause right now and run through on a scrap piece of paper to make sure that you could set up the sine ratio as a fraction and then actually go through and divide to see if you get this decimal to make sure that you're on the right track, more power to you, and I actually suggest you do try that. Try that for sine D, cosine D, sine and cosine F. Okay. Pause, run through, and then see if you can get those decimals, much like we did for example 1A. That would be good practice, but definitely not required. If you want to see what the fractions are, they are done on my completed notes. All right, so moving on. Much like example 2, where we talked about yesterday or in 13.1 notes on tangent, example 2, like there, where we had to go through and figure out or use tangent to figure out the missing side length, we're going to use sine and cosine to find the measure of an unknown side length. So, if we look at example 2, part A, they want us to go through and find the measures of BC and AB. Now, key thing that you need to do when you get to any of these problems, okay, so we're going to just go through and figure out what X and Y are for this one. We're going to take it one at a time. But the first thing you need to do, anytime you get to these, identify the angle measure they tell you, which in this case is A. Okay, so we know that A is 11 degrees. So angle A is going to be my reference angle. Then you want to go through and identify your opposite, adjacent, and hypotenuse sides. So that way we can go through and figure out if we need to use sine or cosine. So the side opposite our right angle is our hypotenuse, in this case 12. The side opposite our reference angle, the angle we know 11, is this BC or X. So this is opposite. So if I know that this is the hypotenuse, this is opposite, that means that Y is the adjacent. All right, so if we want to figure out BC first, so that's going to be our first one. BC is this side length here with x. If we go through and figure that one out first, to know if you should use sine or cosine, okay, we need to figure out what two letters, okay, is it O and H or A and H to indicate us to this. So we want to figure out BC. Well, BC is O, and then we know the length of the hypotenuse is 12. So I need to figure out what my opposite side is, and they tell me what my hypotenuse is. So I have O and H. Well, O and H is going to indicate me to sine. And I can put TOA on here as well, just as a reference. So O and H only is in the SO, because this is A and H and then O and A. So O and H indicates sine. So we're going to do sine 11 is equal to opposite over hypotenuse. The opposite is the x, and then the hypotenuse is 12. So I have sine 11 equals x over 12. Much like the 13.1 notes, when x is on top, all I have to do is just multiply this 12 in front. If x was on bottom, like I'll show over here, then you would have to flip the place of the sine 11 and 12. But because 12 is on the bottom, all you have to do is multiply it over. So it's 12 times sine 11 equals x. Now remember to make sure that your calculator is in degree mode. So this says DEG, we're good. If yours doesn't, remember hit the DRG button and make sure that you are highlighted under DEG, not under GRD or radians. You want to be under DEG. All right, so if we do 12 times sine 11, so we're going to use the sin, SIN button, sine 11, and we're going to end up with 2.289, and I'm going to round to 2 decimal places, so we're going to call this 2.29. And that is the length of BC. All right, so next we need to go through and figure out the length of AB. So AB is this side length right here. That's my adjacent. So we have the A, and then I know my hypotenuse, which is 12. So that's H. So we have A and H. So the trig ratio that uses A and H is not sine, it's not tangent, but it's cosine. Okay, so cosine is adjacent over hypotenuse. So we're going to do cosine 11 is going to be equal to its adjacent, so that's y, over hypotenuse, which is 12. So we have cosine equals y over 12, or cosine 11 equals y over 12. Again, the y or the x is on top, the number's on the bottom, so we can just multiply that 12 in front. So we're going to do 12 times cosine 11 to figure out the length of y. So we do 12 times cosine 11. So we're going to use cosine instead of sine or tangent. And when we do that, we get 11.779. So we're going to round this to 11.78. And that is our answer for the length of AB. And that's how you do part A. Now, I want to do one more in practice, just so that way you can feel confident about when or should I use sine or cosine. So if we look at part B, they want us to figure out the length of ST. Now, if we look at our triangle, they tell us that angle S is 54 degrees, and that UT is 87 degrees. And we know that angle U is the right angle. So if I know that angle U is the right angle, that means that I know that ST is the hypotenuse. And then using the 54 as my reference, okay, the side opposite of the 54 is 87. And then the side adjacent is going to be SU. All right, so I figured out my hypotenuse, opposite, and adjacent sides related to the 54 degrees. Now, two things here. We know that 87, so I know my opposite, and then they want us to figure out ST, which is this side length here. So we need to figure out what ST equals, and they tell us that this side length is 87. I don't know anything about the adjacent, so that's not going to be anything we need to use. I know the opposite, and we want to figure out the hypotenuse. So O and H, which one uses O and H? It's sine, because sine is opposite over hypotenuse. The O and the H, A and H, O and A. So we're going to do sine. They tell me my angle measure, so we're going to use 54. And then that's going to equal its opposite over hypotenuse. So the side opposite is 87. And then I don't know what the hypotenuse is at this moment, so we're just going to call it x. So we have sine 54 equals 87 over x. Like I talked about in the 13.1 notes, when x or y is on the bottom, okay, we're going to flip the place of x in sine 54 to give us x equals 87 over sine 54. If x is on top, like we saw with example A, all you have to do is just multiply that bottom number in front. So we did 12 times sine 11 or 12 times cosine 11. So again, if the number's on bottom, multiply it over in front. If the number's on top, so like the x is on the bottom, just flip the x in the sine 54. So you're going to do 87 divided by sine 54. And if we type that into our handy dandy calculator, we end up with 107.54 for the length of ST. So the key thing when you get to problems like example 2, and they want you to use the sine and cosine ratios to find unknown lengths, first of all, use your reference angle to indicate what the opposite, adjacent, and hypotenuse are for your triangle. Once you have identified your opposite, adjacent, and hypotenuse side lengths, the next thing you need to do is look at what side length measure they tell you. Is that your opposite, adjacent, or hypotenuse? And then use whatever side length they want you to find. So in this case it was the hypotenuse, and they told me my opposite. So that means I need to use the trig ratio that uses O and H, and that tells me sine. Over here, if we wanted to figure out y, that's my adjacent, and they tell me my hypotenuse, so I have my H and my A, and the only one that uses H and A is cosine. So figure out your opposite, adjacent, and hypotenuse based off that angle they tell you. Take what side length they tell you, what measure they tell you that is, as your opposite, adjacent, or hypotenuse to tell you, and then also what side length you need to find. Use those two to indicate the trig ratio. Okay, is it using the opposite and hypotenuse? Is it adjacent hypotenuse or opposite and adjacent? All right, so with that said, that is example 3 on applying the sine and cosine ratios to find side lengths. The next part is going through and finding angle measures. So example 3 is just like example 3 from the 13 13.1 notes for the tangent ratio. So to find the measures of the acute angles, the non-right angles, you can use the sine inverse of A, the inverse sine of A, and the cosine inverse of A, read as the inverse cosine of A, to find the measure of angle A. Doesn't matter whether you use cosine or sine, it just depends on what information they tell you or what information they provide for you, much like we did with example 2. So keep in mind, SOHCAHTOA as you do these problems. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when you are finding the angle measure, we're going to use the sine and cosine inverse for this example. So it says find the measure of the indicated angle and round to the nearest degree. So if we look at example 3, part A, the first one they want us to find is the measure of angle Z. They give us the right triangle XYZ. They tell us two side lengths, 23 and 14. So if we look at angle Z as our reference angle, first of all, in this triangle, the side opposite our right angle is 23, so that is going to be our hypotenuse. Now that I know the hypotenuse, we can go through and identify the opposite and the adjacent. The side opposite of Z is 14. And then the side that is adjacent is unknown. Alright, so to figure out Z, now they only tell me two side lengths, and that is the opposite and the hypotenuse. I don't know anything about the adjacent, so we're going to ignore the adjacent for the measure of angle Z. So it leaves me with the opposite and the hypotenuse. Between sine, cosine, and tangent, which one uses H and O? Okay, the only one that uses H and O is sine, so we're going to do sine of Z opposite over hypotenuse, so it's going to be 20 or 14 over 23. Sine is opposite over hypotenuse. The opposite is 14. Hypotenuse is 23, so 14 over 23. Now, that's finding the trig ratio. So to figure out the measure of the angle, this is where we're going to use the inverse. So we're going to do sine inverse 14 over 23. So if we do sine inverse of 14 divided by 23, we end up with 37.49. So we want to go through and round for this, and we are actually, because of our indication, if we go all the way back, so this 37.495, this 5 is going to indicate to us that we need to round up, just like the 9 indicates to round up as well. So that makes this a 5. So 37.5, for rounding to the nearest degree, this needs to be 38. Okay, if it was 37, it's not going to match up based on what we figure out for the measure of angle Y. Alright, and that is how you find an angle measure using sine. Alright, now we can go through and use sine and cosine to figure out the measure of angle Y, which I will do for this one. I won't run through both of them for part B. We'll just use 180 minus. But I want to verify for you why we needed to have it to be 38. Because if we went through to figure out the measure of angle Y, if we use Y as our reference, again, 23 is always the hypotenuse. The side opposite is going to be unknown, but I know that my adjacent side is 14. So the two things that I know is I know my hypotenuse and I know the adjacent. So if we know the hypotenuse and we know the adjacent, which trig ratio uses A and H? The only one that uses A and H is cosine because of the ka. So we would do cosine y equals 14 over 23 because it's adjacent 14 over hypotenuse 23. So to figure out y, we're going to do cosine inverse of 14 over 23. And if we do cosine inverse of 14 divided by 23, we end up with 52.5. So we're going to round this to 52 degrees. All right, so that is how we go through and find the measures of different angles. Now, because that was 52.5, we could classify this as 53 degrees, but that would mean that this needs to be 37 degrees. So if rounding is ever off, just know that you just have to change one of them by one or two, or by one, sorry. So if we round it up, maybe it needed to be stayed the same, whereas the other one might have needed to be rounded up instead of staying the same. All right, if we look at B, so for part B, we need to go through and figure out the measure of the angles again. So for part B, if we need to figure out the measure of angle P, okay, P is going to be my reference angle. First of all, the side opposite of my right angle is 13, so that's my hypotenuse. So then, using angle P as my reference angle, I do not know the measure of my opposite side, but that is RQ. And then the side that's adjacent is 7. So the two things I know is I know that my adjacent is 7 and that my hypotenuse is 13 for angle P. So adjacent and hypotenuse are my two knowns. So if I know my adjacent hypotenuse, that's A and H, the trig ratio that uses A and H is going to be cosine. So we're going to do cosine P equals adjacent over hypotenuse. It's going to be 7 over 13. So we'll do cosine inverse of 7 over 13 to tell us what P equals. So if we use our calculator to go through, so second cosine, 7 divided by 13, we are going to end up with 27 point, or sorry, not 27, I'm reading that backwards, 57.42. Because that's a 4, that means that it's going to stay the same. So 57 degrees. Now, if you're wondering why did I keep this as 57, because that was 4 and I rounded up on the other, it's because the numbers behind it would have indicated to round up. Again, okay, if you typed in 38 and it didn't say it was right, you could try 37 if that was right. Then you know that you're on the right track. Some of these get down to a little nitty gritty. Some of them are more clear and straightforward, like we see with B. So if we know the measure of angle P is 57 degrees, I'm going to write it in here for matter of purpose. If I know Q is 90, P is 57, to figure out R, all we would have to do is just do 180 minus 90 minus 57, and that would give us 33 degrees. which if we went through and did the math using sine inverse of 7 divided by 13, we would get 32.57, which rounds up to 33 degrees. And that is how you go through and use sine and cosine to find the measure of an angle. So, with that said, that is it for our notes today on section 13.2, sine and cosine. So we've now talked about tangent, sine, and cosine. So we've now talked about the three main trig ratios of sine, cosine, and tangent. So we've talked about their ratios. The SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, I cannot implore you enough that SOHCAHTOA is extremely helpful. And trust me, it is helpful to go through and write it down. There's no shame in it. Can't tell you how many students I see with a quiz or on their homework or on a test will just write it out. It does help keep things straightforward for you. So, with that said, that is it for our notes today on 13.2. Again, I know a little bit of a longer video, but thank you guys for listening. I really do hope this was helpful and you have a good understanding of sine and cosine, how to find their ratios, and then how to use sine and cosine to find side lengths and angle measures. So, with that said, that is it for today. Thank you for listening. As always, please use the completed notes as you work on the homework, and if you have any questions or need any help, just let me know via email or next time you see me, and I will be more than happy to help. So, with that said, that is all I have for you guys today. Thank you for listening. I'll talk to you guys later. All right, bye.